This is a block of solid, crystal-clear ice, and this is the scorching, 140-degree sand of the Persian desert. In the ancient world, these two absolute opposites did not just exist together, they were mass-produced. Now, think about that for a second. Imagine standing in the middle of the Iranian desert during the height of summer. The sun is a blinding white disk, baking the ground to a blistering heat. The air is so dry it cracks your lips in minutes, and the heat feels like a physical weight pressing down on your chest. In this hyper-arid wilderness, survival is a daily battle. Yet, 2,400 years ago, in the heart of the ancient Persian Empire, this was a daily reality. Long before the discovery of electricity, mechanical compressors, or even the basic understanding of modern chemistry, ancient Persian engineers were mass-producing ice in one of the hottest environments on Earth. But they didn't haul this ice down from distant, snow-capped mountains. They didn't import it across thousands of miles of burning trade routes. Instead, they manufactured it right there in the middle of the desert, using nothing but mud, wind, and water. Even more mind-bending is how they did it. They didn't rely on chemical tricks or simple evaporative cooling. They manipulated the fundamental laws of thermodynamics to turn the cold vacuum of outer space into a giant thermal heat sink. They literally pulled the cold from the cosmos. This is the story of the Yakhchal, an ancient thermodynamic marvel that defied the desert, rewrote the rules of logistics, and proved that sometimes the most advanced engineering doesn't conquer nature. It whispers to the stars. To understand the magnitude of this achievement, we must first look at the logistics of power. In the ancient world, ice was far more than a luxury. In a massive, centralized superpower like the Achaemenid Empire, which spanned from Egypt to India, managing resources was the ultimate test of statecraft. In these vast desert territories, heat was the enemy of progress. Food spoiled within hours, diseases ran rampant in warm water, and the ruling class demanded a way to project their supreme authority over their harsh environment. If you think ancient humans were primitive survivors who spent their days rubbing sticks together for fire, you've been completely blinded by modern arrogance. To the Persian kings, serving chilled wine and frozen desserts in the middle of a triple-digit summer was the ultimate display of wealth and logistical dominance. But how do you get ice to a desert city like Yazd or Kerman? The nearest snow-covered peaks were hundreds of miles away, separated by vast stretches of sun-baked rock and sand. If you tried to transport a wagon of mountain ice across these trade routes, the blistering heat would reduce your cargo to warm vapor long before it reached the city gates. The thermodynamic cost of transport was simply too high. If ice could not be imported, it had to be manufactured on-site, and this is where they faced an apparently unsolvable paradox. According to the common sense of the ancient world, to make something cold, you must place it in contact with something colder. But in the Persian desert, every single element of the environment is hot. The ground is hot, the air is hot, the wind is hot, and the water flowing from underground springs is warm. How do you force water to freeze when the ambient temperature refuses to drop below 80 degrees, even at night? This was the absolute logistical and physical crisis of the desert empire, the sheer impossibility of local ice production under a relentless sun. To solve this, the Persians designed a revolutionary technology called the Yakhchal, a giant mud brick thermodynamic machine engineered to violate the thermal limits of the desert and freeze water, where no cold existed. The physical manifestation of this breakthrough was the Yakhchal. To a modern traveler, a Yakhchal looks like a giant clay-colored cone rising out of the desert floor, resembling a strange alien monument. But this structure was not ceremonial, it was a highly sophisticated thermodynamic system. Now, here's the thing. The system began miles away, deep beneath the mountains, with another legendary Persian innovation, the qanat. The qanat was a network of underground aqueducts that tapped into subterranean mountain aquifers, carrying cold, freshwater gravity-fed over vast distances directly into the desert settlements. Because these channels were buried deep underground, the water was shielded from the scorching sun, arriving at the settlement relatively cool, but still far above the freezing point. When this water reached the Yakhchal site, it was directed into long, shallow channels dug into the earth. Crucially, these channels were oriented from east to west and shielded on their southern side by a massive, incredibly tall mud brick wall. This wall was a masterpiece of passive solar design. It was carefully calculated to cast a deep, permanent shadow over the water channels throughout the entire day, completely blocking the intense desert sun. Most people assume that ancient engineering was just primitive trial and error. It wasn't. It was calculated thermodynamics that would make modern mechanical engineers sweat. On paper, this design seemed flawless. By keeping the sun off the shallow pools of water, the engineers minimized the thermal energy absorbed by the water. They hoped that as night fell and the desert air naturally cooled, the water would freeze. But there was a hidden, devastating physical problem. In the desert, even when the sun goes down, the ambient air temperature remains high, often staying above 60 or 70 degrees Fahrenheit due to the thermal mass of the surrounding sand. Convective heat transfer from this warm air constantly brushed against the surface of the water, keeping it warm. Simply shading water is not enough to make it freeze when the surrounding air is hot. The water should have remained liquid, eventually evaporating into the dry air. The system was dead in the water until the Persian engineers discovered a cosmic loophole that should not exist. This is where the ancient Persians executed one of the greatest scientific breakthroughs in human history, thousands of years before the formal laws of thermodynamics were even written. They discovered the phenomenon of passive radiative cooling. To understand this, we must look at the universe through the lens of electromagnetic radiation. Every object with a temperature above absolute zero emits energy in the form of infrared light. The warmer the object, the more energy it radiates. When you stand near a hot campfire, you feel this infrared radiation warming your skin. Water, too, is constantly radiating its thermal energy outward in all directions. However, under normal circumstances, this energy cannot escape. The Earth's atmosphere acts like a thick, insulating glass greenhouse. It traps heat, bouncing it back down to the ground. But there is a secret vulnerability in this atmospheric shield, a highly specific physical phenomenon known to modern physicists as the atmospheric infrared window. Think of it as a thermal keyhole, a physical gap where the greenhouse glass simply disappears. Between the wavelengths of 8 and 13 micrometers, our atmosphere is almost completely transparent to infrared light. If an object can emit radiation precisely within this narrow spectral window, that radiation will pass clean through the clouds, the greenhouse gases, and the atmosphere, traveling unimpeded into the absolute freezing cold of outer space, which sits at a chilling -454 degrees Fahrenheit. The Persian engineers, through meticulous observation and trial and error, figured out how to exploit this cosmic loophole. They realized that on clear, dry desert nights, the humidity in the air drops to almost zero, making the atmospheric window incredibly clear. By building the tall walls to block the warm desert winds and shield the channels from the daytime sun, they created a perfectly stagnant microclimate. At night, the water in the shallow channels began to emit its thermal energy as infrared radiation. Because the sky was clear and the air was dry, this heat did not warm the surrounding air. Instead, it shot directly through the atmospheric window, escaping into the infinite vacuum of space. The water was literally beaming its heat into the cosmos. As a result, the water lost its thermal energy at an astonishing rate. Even when the ambient air temperature was as high as 45 degrees Fahrenheit, the water's temperature plummeted below the freezing point, forcing it to crystallize into solid ice. They had achieved the impossible, freezing water in the middle of a hot desert, using nothing but the cold of the universe. The successful manipulation of radiative cooling was only the first step in a massive logistical operation. Once the ice was created in the shallow, shaded trenches during the cold desert nights, the Persians had to harvest and store it before the first rays of the morning sun could melt their hard work. Every morning, before dawn, teams of workers descended into the trenches. They broke the thin, freshly formed sheets of ice and quickly transported them into the heart of the Yakhchal, the massive conical dome. The design of this dome was a thermodynamic masterpiece in its own right. The walls of the dome were up to 2 meters thick at the base, constructed from a highly specialized, proprietary mortar called Sarooj. Sarooj was a complex mixture of sand, clay, egg whites, lime, goat hair, and ash. This unique material was not only incredibly tough and resistant to water erosion, but it also possessed extremely low thermal conductivity, acting as a massive barrier against the external desert heat. Inside the dome, a deep subterranean pit dug into the dry earth served as the primary storage chamber. Because cold air is denser than warm air, it naturally sinks. The Yakhchal's shape exploited this fluid dynamic. The heavy, freezing air wrapped around the stored ice at the bottom of the pit, while any warm air that managed to seep in rose to the top of the conical dome, escaping through a small ventilation opening at the very apex. Massive wind catchers or badgers were often integrated into the structure, funneling even the slightest breeze down over subterranean water channels to pre-cool the air before it entered the dome. The results of this system were staggering. Thousands of tons of ice, harvested during the winter nights, could be preserved in these structures throughout the entire year, surviving the brutal 120-degree summer heat. This allowed the empire to maintain a continuous supply of ice for food preservation, medical treatments to cool fevers, and the creation of falud, a delicious dessert of starch noodles frozen in rosewater, lime juice, and sweet syrup, which was distributed to both royalty and the public. The Yakhchal transformed ice from a rare geographical luxury into a reliable mass-produced resource that fueled the empire's administrative and military expansion. The Yakhchal forces us to confront a deep, cognitive bias about human history. In the modern world, we often equate progress with energy consumption. When we want to cool a room, preserve food, or manufacture ice, our automatic reaction is to build a louder machine, draw more electricity from a coal-fired power plant, and pump chemical refrigerants and greenhouse gases into our warming atmosphere. We solve thermodynamic problems through raw, industrial brute force and massive energy inputs. But the ancient Persian engineers showed us an entirely different path. They achieved the exact same thermodynamic result, cooling water below its freezing point in a scorching desert with zero electricity, zero emissions, and zero environmental degradation. They didn't fight the environment. They understood its laws so deeply that they turned the environment itself into the solution. They didn't fight nature. They cooperated with the cosmos. Today, as humanity grapples with the catastrophic consequences of climate change and soaring global energy demands, modern scientists are looking backward to move forward. Researchers at institutions like Stanford and MIT are currently developing advanced passive radiative cooling materials. These are high-tech paints, polymers, and metamaterials designed to reflect 97% of sunlight while simultaneously radiating heat within the exact same 8 to 13 micrometer atmospheric window that the Persians exploited 2,000 years ago. Applied to the roofs of buildings, these materials can cool interiors by up to 15 degrees Fahrenheit without consuming a single watt of electricity. It is a revolutionary technology that could drastically reduce our reliance on air conditioning, which currently accounts for a massive percentage of global greenhouse gas emissions. Yet, this cutting-edge space-age solution is, in reality, a direct mechanical descendant of the mud brick Yakhchal. The realization is profound. The ancient Persians weren't primitive innovators working with crude tools. They were master thermodynamicists who understood the cosmos on a level that modern science is only now beginning to fully appreciate and replicate. Today, if you travel through the arid plains of modern-day Iran, you can still see the weathered, majestic domes of these ancient Yakhchals standing silent against the desert horizon. Many of them have survived for centuries, outlasting the empires that built them, the kings who ordered their construction, and the qanats that fed them water. They stand as quiet, mud-brick monuments to a time when human ingenuity was measured not by how much energy we could burn, but by how elegantly we could cooperate with the natural laws of our universe. They remind us that the limits of our world are not always barriers to be broken with high-tech brute force. Sometimes they are invitations to look upward, to study the stars, and to find elegant, silent pathways through the physics of the cosmos. The next time you listen to the hum of a modern refrigerator or enjoy a cold drink on a hot summer day, remember the ancient engineers of Persia. Remember that thousands of years before the first light bulb flickered to life, humans had already figured out how to reach past the clouds, tap into the infinite cold of outer space, and build a factory of ice in the middle of a burning desert. They didn't conquer the desert. They simply taught the sand how to freeze. If you enjoyed exploring the invisible mechanisms that drive empires, consider subscribing for more deep dives into the hidden logistics of history.